We'll talk about switch statements in this video. Switch is a composite statement used to make a decision between many alternatives. So you can also think of a switch case as an alternative to a whole bunch of if, else if, right? So on and so forth, allowing a programmer to make multiple decisions depends on what the condition is. So let's explore a couple of use cases and also the syntax involving this switch. This is the anatomy of a switch statement involving use of case and default. So switch itself is a statement without a semicolon, right? It's encapsulated in this pair of curly braces, inside of which there's a whole bunch of cases and a default. So what happens is switch involves use of what we call constant expression. Okay, so this constant expression evaluates to a constant, right? Namely a literal, like 1, 2, 3, 4. And this expression must be a constant integer or integral, okay? Integral, literal. So that said, these constant 1, constant 2, constant 3 must match, right? The value of this expression. Let's say if the value of the expression is 1, and let's say if this is 0, right? And this is 1, and this is 2, then upon matching 1 to 1, this switch is going to be hitting this case after it, bypassing this 0 in general, and bypassing this unless, right? Later on, we're going to look at the use case where this following case will be evaluated because there is no break. So that said, this expression matching the constant is of paramount importance. The default itself is evaluated, assuming none of the cases matches, right, this expression, this constant expression. And then at the end, you have the end of switch. This is a quick demonstration of switch statement. Let's say this print flag is a constant expression that evaluates to a number, a positive number, 1, 2, 3, 4, 1,000,000, 2,048, right, etc. So if this, let's say this print flag equals 1, then what's going to happen is this is the case 1 will be printed to your console, right? Print stuff over to your console. So that would be the case. And then what would happen is, since there is no break, right, as the second statement after printf, then what's going to happen is your flow control is not going to stop here. It's going to keep going to case 2, and case 2 prints, this is case 2. And then because there is no break here, right, break is a statement, right, then flow control is going to go on to the default, which prints this, right? At the end, this default prints this is default, and then the flow control is going to get to the end of the switch, and that will be the end of this entire switch power flows from beginning to end. Therefore, it is important to have a break, okay, break statement at the end of each case. For example, if printf, right, or print flag itself is not 1 but 2, then it's going to jump to 2 and print out default as well. Let's say printf is 1,000,000, right? Obviously, case 1, case 2 will not satisfy that constraint. In that case, the print flag will then jump straight to the default and get this is default printed to the console instead. This is another use case that illustrates pretty much the same thing, but this time with break. As you can see here, if print flag equals 1, then what's going to happen is there's nothing in 1, so it's going to go to 3, and 3 is going to print good day, as have it, and then break. And this terminates the flow of control in this switch. That will take your entire program out of this entire switch case to line 18, right? They will jump right into the 18, bypassing 2, 3, and default and that stuff. Let's say if the print flag instead is not 3, but let's say it's 2. What will happen is your flow of control is going to land on here, line 10, but there's nothing in line 10, and there's nothing stopping the flow control from moving forward. Your flow controls go on to 11, which prints case 4, right? Even though this print flag is not 4, but it will, by way of 2, go to 4, and it's going to print all that stuff out and a break, right? This break then takes the flow control out to line 18 at the end of the switch. Okay, so that said, you can move on with other values of print flag. Let's say print flag is 1000. In this case, none of this is going to satisfy. It's going to jump 1000 straight to default, right? So your switch simply matches the expression, your constant expression, to any available use cases that has a constant value associated with it. If none is found, it will take your flow of control to the default, and the default will be evaluated. Now, you don't necessarily need a break, because at the end of the default, you're already at the end of your switch, right? As soon as this is over, right, line 15, it will take the flow control to line 17 and then 18, so on and so forth. So this break is pretty much redundant, so you don't have this. You don't have to have this. So let's review this, right? So the control expression that follows the keyword switch must be an integral type, right? So we talked about switch. So this must be an integral type. It cannot be a char, okay? Like actually it can. Char is an integral, but it cannot be a string, for example, like this, right, with a double quote. It cannot be a double, right? 0.2, for example. So you can't do any of that stuff, but you can have integral type sitting inside this. That's number one. Each case label is the keyword case followed by a constant expression, right? So whatever this value is, you can have the same thing pretty much inside the case. So this case, this constant expression must be a value, integral value as well. No two cases label can have the same constant expression value. So you can have, right, case, like this. But let's say if the first case is 100, you cannot have another 100 underneath it. There's only one, okay, 100 here. So that speaks for this one. The default value is not, so just default label, right? So we saw default, right, all the way at the end. Now, technically, the default doesn't have to be at the end. You can have the default here. You can have the default here all the way up front. It doesn't really matter, but it is customary to have default all the way at the end. It's almost like having a if, right, statement, right? At the end, you have this else, right, that covers the rest of the problem spaces. So you have the default pretty much at the end, but having it forward in between cases is not a problem. It's just that it's not a very customary thing to do, and it makes your code hard to read. Okay, so that's pretty much all of this. Let's move on to other use cases. This is a sample code that illustrates how to convert a numeric score into a numeric representation of the grade. First, this program asks the user to enter the test score, right? So the user, in this case, presumably a teacher, enters a number, and this program gives a letter grade out of it. So this is a local declaration statement and the function declaration. We haven't talked about functions yet, but just quickly illustrate the use of switch. So you have this function called score to grade. So you can think of this function as a block of logic that computes majority of your business logic, right? Sits in there that computes a letter numeric score into a letter grade. So inside of this score to grade from line to 31 and so on, is where the majority of the work happens. So we'll also see an example of a switch case in this. So let's move on to the next part. So this is the bulk of the logic right here, right? 31, 39, all the way through 53. So as you can see, temp, right? If you go back to the previous slides, a temp is a score divided by 10. So let's say if your score is 100, then divided by 10, that's going to give you 10. Let's say if the score is 101, right? Divided by 10, that's, again, going to give you 10. So remember, temporary, so this temp, right, variable is a quotient, right, not a remainder. So in this case, let's say if you your temp is 10, right? 10 is the same as 9. So let's say if somebody got a 90, right, or even 100, so even 91 or 92, 93, right? That's all going to give you, either 10 or 9, depends on what you have. Like you can have hundreds. So as long as you've been between 10 and 9, you get a letter grade. So this grade, which is a char, right, is is A, right? And then breaks. So this grade then returns, right, what this value is at the end. However, if you have somebody who received a 89, right, or even 80, so what happens is when you said, let's say 89 divided by 10, what does that give you in C, right, or even C++? It's 8, right? Remember though, not 8.9, okay? Because we're talking about this integer divided by integer gives you an integer, and all of your decimals is not going to be involved. So this is the implicit conversion of the data type that we went through several weeks ago. The use case apply also to, let's say you have 78, right, 77, right, or even 70. That's going to give you letter C, right, 7. This integer 7 will translate to a grade of C, right, and then you can have 69, right, even 60. That's going to give you this, right. So division, or in other words, a temp equals, you know, score divided by 10 gives you 6. You see a D and stuff like that. Now, if you don't have any of these, okay, none of this matches, then it goes into default, which means you basically received a 59, right? 59 below, all the way to 0, you get an F, okay? Upon which, as you can see here, default doesn't carry a break statement. It is simply not needed because as soon as line 50 is evaluated, it goes into line 51, which is at the end of the switch that takes you to the return type. So that's it. This is a switch illustration. So this is the same example as the one that we had using a switch case. However, instead of using a switch case, we decided to use instead a whole bunch of if files, right? So we talked about this earlier before, and that if every time you wish to use a switch case, you can convert those switch case into if and else. Okay, so I'll have another video that illustrates the other example that we can get into it. So as you can see here, instead of using switch, you start up with what your, right, the very first condition is. And then as you can see, every single one of these if else, right? Let's say if this is your problem space, this part, right, is if, and then you have this else if right here, and this portion is else if. So this divide and conquer at the end, right? You have the rest of the problem space incorporated using else. So this will take care of letter A, B, C, D, and F, right? There's no more. So at the end of each, you can return your grade. If and else statement allows you to, a programmer to group various different logic. So you can consider something 1 as logic 1, logic 2, logic 3, logic 4, so on and so forth, depending on what a condition is. So in case, if an integral value val, right, equals 1, then you have a group of logical statements to be evaluated under this something 1, so on and so forth. So a lot of times when you have a pretty complicated structure where you have a whole bunch of logical compartmentalization involving else if, right? If you have way too many of those, the best practices in software engineering is to convert these into a switch statements, because you don't want to have this giant if and else, right? And a lot of these something 1, 2, 3, they could be like 10, 20 lines, 30 lines of code. You never want to do that, right? But of course you can think about, you know, making these logic into a private function where you can call these functions individually, but that's not the point. The point is for every single if, else if, and else, right? These type of conditional structures, you can convert them easily into a switch case. So let's examine some of the details that we see in switch case, and then we'll illustrate this with using a code examples later on. So let's move on to the second part, which is the details. So a lot of times what you do is when you write switch case, in the past, I've seen people using this curly braces to encapsulate these various different statements. And these are your logic, right? Associated with this use case number 1 and case 1, right? 1 is where that switch statement evaluates to from an expression standpoint. You don't really need this curly braces, but just to understanding, a lot of times what developers will do is they'll indent this, right? So this is indentation, right? So it's basically a tap, okay? So you can tap the entire statements over. So it's understood that, let's say if your statement has maybe 10 lines, and all these 10 lines will be evaluated under this case one, okay? And then we'll talk about, you know, how to break your switch case. And obviously, when the case is over, right? When you're done evaluating all of the statements, the very last one should be a break, unless you intentionally wanted to have the flow of execution to go through the entire cases, meaning after case one, you want to evaluate case 2, 3, 4, 5, so on and so forth. Otherwise, you'll end it with a break, and break semicolon, okay? So that's it. At the end of the statements, and there is also the default case. So default case is where this is basically the catch-all. And you can think of this as equivalent to the else statement, right, inside the logical control structure. So they're kind of similar. This is what we call the catch-all. Okay, so where your logic is not captured in any of these use cases, case 1, 2, 3, 4, 5. You have a default one in case your expression evaluates to something none other than any of these cases you have listed, it'll go into the default. And then in a default one, you don't really need to break, because at the end of the default, you're done. Okay, so let's look at some of the code examples that illustrates a switch case to aid more understanding. All right, this is one of the IDEs that we're using online. What you see here is a bare bones C++ program with nothing in it. So we're going to write a simple switch case. Here, as you know, switch case statement evaluates an expression, matching the expression's value to a case value. So let's just say this switch case has a value of 1, right? In general, what's inside the statement could be any integral type. It could be enumerations, it could be a Boolean, it could be char. In this case, we're using integers, right? So if this integer matches case 1, which is indeed the case, let's just say we're going to see out, right? 1, right? And then we're going to end this with the NL and then break it. We'll do the same thing, right, with case 2. In this case, case 2 will print out 2, and then we'll break it, and then we have a default. And default is the catch-all. Like I said earlier before, when none of the cases evaluates to either 1 or 2, it would just print out this thing, right? So let's just say this is done. You don't really need a break at the end. So this is the complete switch case. So let's run it. This should give us 1 right there, as you can see here. Now, why don't we take this out and say, hey, this is a integer I, right, equals 1. And we use I here, right? And of course, this is not going to change the logical statements that we have there. The execution will evaluate everything into this cout equals 1 on console. Now let's just change this a little bit. Let's just change this to Boolean, right? And of course, we can know Boolean I, right, could be a value. So this basically says I equals true, right? And this will evaluate, but of course, you have to be a little careful. This is a warning, right? Warning doesn't mean that this is an error, which means that the code will still continue. So IDE is actually smart in that respect. It's cautioning you, hey, you have a Boolean here, you shouldn't have a 2 here, but what are you doing, right? So what if we change the char? As you know, char is a integral type, right? It carries an ASCII value, and so it's an integer basically. And it will give you, and so if you convert this into a char, this will fly, right? So a lot of times, you know, you can think about what you need to put inside the switch case. Just remember the switch statement evaluates an expression, matching the expression's value to a case clause, and executes the statement associated with the case. So in this case, there's only 2 statements. One of them is that cout, and the other one is break. So break, right, takes the entire execution out of that entire switch case, exiting the switch case completely. If you don't have break, so what's going to happen is, 1, right, after evaluation of line 18, it'll go into case 2, right? And because there's no break, the flow of control is going to simply just go straight down, evaluating all of the cases. So if you print this, you can see by eliminating the break here, the flow of control is going to go through 1, 2, right, and done, right, as you can see here in the outputs. So this completes our illustration of switch case. Of course, you can always think about converting switch case back into a whole bunch of if else if, else if, else if, right? And then else. There is equivalent. A lot of times people use switch case because it's a lot easier to visualize versus writing a whole bunch of else if, right? Which can get very confusing after going through this entire code for the whole page. It'll be very hard for developers to keep track of what's going on, right? Let alone maintaining the code. So this completes our illustrations on switch case.